Hello, everyone. Today, Z-Motion Technology will show you knowledge about how to achieve machine vision function by Z-Motion RT Basic and Qt. As we all know, Qt is one C++ development framework. It has full GUI graphic library. And its interface controls formats, layouts can be set directly in control property. Obviously, for machine vision that needs HMI interface, the vision development will be easier because of Qt powerful interface design function. Then, Z-Motion VPLC Vision Motion Controller that supports Linux system, which can call Z-Motion RT-Sys RT Basic commands by Qt. Because RT Basic commands are encapsulated as C++ library. RT-Sys is one Z-Motion own IDE software. You can download it and test it by simulator. There are many routines you can check. RT Basic is the main development language. It can program many motion control and machine vision functions. Okay, the first lesson, how to collect graphics. Before that, we need these materials. 1 Z-Motion VPLC 532E motion controller. 1 camera, 1 lens, 1 24V power, 2 cables, and others. Except these, please download our software RT-Sys, Qt Creator. And download the C++ library file, project file of graphic acquisition. They all can be obtained from Z-Motion website download page. You also can contact with us. After preparing well, let's begin how to use RT Basic Add Qt to capture vision graphic. Step 1. Create new project in Qt. Open Qt Creator, click New Project. Select Application, and the first one. Then click Choose. Enter the project name. Choose File Storage Path. Click Next. Now, no need to set, use the default window type. Okay, done, one new project is built. Step 2. Add library files into new project. When you obtained from website, copy them under the project's directory. Return to Qt. Select project name. Click Add Current Project. Add these two head files at first. Then, CPP file. Please note for DLL file, please manually add the codes. In Profile, double-click to add subcode. In this way, it can call DLL library. Then in main window CPP file, define related head files. That is, add these two codes at the project beginning. Step 3. Define global variable in main window.cpp file. These are variables that will be used. The first one, controller connection handle. Then, int variable, space, and continuous acquisition flag. Also, write them at the beginning. They can be compiled from the up to down. Step 4. Design the program UI. Here, we make simple one. Here, enter controller IP to connect. Here, some actions of camera. Scan the camera, collect the graphic. Make it collect continuously, and stop it. Graphic is shown in this control. And you can know how many cameras. The exposure time can be set here. It can be seen they are made by different commands. What's more, and each control is with separate name. For shown image, we name it as ZV0. Now, we open it in Qt. See corresponding functional codes. See Part 1, Connection at first. There are 4 buttons. Button 1, Scan Controller IP. Right-click it. Choose Jump to Slot. For signal, clicked is correct. That is, when clicked it, entering corresponding slot function. It can be seen contents are shown now. It mainly calls the search function to check all controller IP addresses. Corresponding value will be returned. 0 means the connection is successful. All IP will be shown in the list, that is, the button 2. You can select needed one while connecting. If there is one error code returned, it will not execute down. Please check error details and solve that. Let's see connect button information. Connection states and corresponding return values. Then define the buffer space. Select IP from IP list. Use Qt debug to print selected IP address. Qt debug is used here, which means it should be defined at the beginning. After that, it will convert the IP format to accepted format. Then judge whether it can be connected. It depends on connection handle. If it is 0, openEth command will take effect. Connection is done. If it is not 0, there is problem. Connection failed. Close command will close connection. You can click Ctrl to see command details. Corresponding connection state information will be shown in output window. Then, button 4, obviously, disconnect is used to break down now connection. Check the handle. And close it, clear handle, print unconnected content. Okay, next part, about how to operate the graphic acquisition. Button 1, scan the camera. Here, run task C++ command is used to call our T-basic task. That is, download edited basic file into controller. It will call basic program, execute corresponding actions. Before that, it defines camera numbers, error codes, strings, and the buffer space. Next, call this function. This function mainly writes camera scanning codes. You can contact us for that. Still, return value 0 means it is okay. After scanned, use getTable command to read values from table register. Here, read one value into camera number variable. Corresponding data will be shown in camera number place. Button 2, collect the graphic. As usual, use run task to run graphic acquisition basic function. Then, collected graphic ZV0 will be shown in that control area. Before showing, it needs to convert the format to be valid format of Qt. Also, please add definition codes here. Then, it can be known use this to get image information. Save that into buffer. Because Qt graphic format is pixmap, format should be converted. In this way, ZV0 graphic can be shown successfully. Button 3, continuous acquisition. Actually, same as collect function. The main function is to collect graphics continuously through timer. And there is one flag, one means the continuous acquisition is opened. That is, it checks once after each certain time. It also should be defined at the beginning. Define timer's type, function, and variables. After definition, timer trigger codes are written in initialization. Here, we set the time as 200 milliseconds. Each 200 milliseconds, trigger to capture once, and show the graphic. Button 4, the stop motion. Call the RT basic subfunction to set the flag as 0. Then, it will not open the timer. And stop immediately. Then, let's see how to set the exposure time. It can be seen it gets the exposure value you set. Then convert it to floating format. And save it to controller table 1. Still, use run task to call corresponding function. Okay, now, all processes are introduced. Next, let's connect to the controller to operate it. After wiring controller, camera, power supply. Open Camera Acquisition RT Basic project in RTSys at first. It includes camera scanning, image acquisition, continuous acquisition, exposure time configurations. And while interacting with Qt, Table 0 and Table 1 is used. Then, connect to RTSys to controller. Go to Qt. Run the program. Scan the controller IP. Now IP is shown here. Click Connect. Next, scan the camera. It can be known one camera is connected. Then, collect the graphic once. The information under camera is shown. When we select Continuous Collect, we can move it. It will capture all the time. But if Stop button is pressed, at this time, no update anymore when you move again. Then, set one exposure value. For example, 3000. Obviously, the graphic brightness is lower. Now, full functions of camera acquisition all are shown. Disconnect it. Okay, today's information is over. Next lesson is about how to recognize the graphic. If you are interested in our VPLC Vision motion controllers, please contact us. Thank you for your watching.